In today's lesson, we are verifying solutions for differential equations. So starting out with, here we have a differential equation. And what we want to do is find a particular solution that goes to the point 0, -2. And what I mean by that is we want to find the y function. So if this is the derivative function, we want to find that original y function that goes through this point. And to go from derivative backwards, that's when we're doing integrals. And when we're doing integrals, antiderivatives, we always have that plus c. So the idea is with this information over here, we can find c. So we'll start with, I want you to think about taking the antiderivative, 6e to the 2x, and I'm going to break this up into two integrals. And the only reason I'm breaking it up is because this first term here involves u substitution. So if u equals 2x, dx equals du over 2, so 6 divided by 2 would be 3, and then 3e to the u is just 3e to the u, and then we would plug in that 2x back in. So the first term is 3e to the 2x, and then minus antiderivative here, 4x squared over 2 plus c. And if we started with dy dx, then this is y. So to get the particular solution, we want the y function that goes to this point. So we have to solve for c by plugging in x and y. So I'm going to plug in -2 for y. 3e to the 2 times x is 0. Minus, this will just go down to 2. And then x is 0 squared plus c. So -2 equals, this term cancels, this turns to 1, so I have 3 plus c, so c equals -5. So all I have to do now is go back here and substitute in my c. So y equals 3e to the 2x minus, simplify that, 2x squared minus 5. So now the idea would be, if you take the derivative of this, can you verify that you went backwards to where we started? So the derivative, let's see, this would be chain rule. So 3e to the 2x times 2 is 6e to the 2x. And then power rule, if this would bring down the 2, so minus 4x, and the constant would fall off. So it worked. Okay, we're going to do that process one more time, starting with this differential equation. dy over dx equals 10 sine of 5x. So we want to find the particular solution that goes to the point pi over 5, 1. So if we're going to take the antiderivative of 10 sine of 5x dx, you've probably done enough of these. This is u substitution, but I bet some of you could just kind of do this in your head. U is 5x, therefore dx is du over 5. So this I will be dividing by 5, and then let's do this. So we would turn into 2 sine of u du. So then the antiderivative of sine is negative cosine. So this would be -2 cosine of 5x plus c, and this is y equals. So if we plug in this x and this y, we can find c. So y is 1 equals negative 2 cosine of 5 times pi over 5 plus c. So here the 5's cancel. Cosine of pi is negative 1. Negative 2 times negative 1 is 2. So 1 equals 2 plus c. So c equals negative 1. And then go back here, rewrite y equals negative 2 cosine of 5x minus 1. And if you were to take the derivative of what we just got, we would go back to where we started with that differential equation. All right, and here's the last example for the video. It's going to sound a little weird, and the process you might think is a little weird and looks crazy and confusing, but it actually ends up not being too bad. It starts with, so what value of k? So we're finding a k. So that we need to find that value where this y equals would be a solution to the differential equation. So y double prime plus 16y equals this. So we need to create an equation where we solve for this k. So what we're going to do, so if y equals all of that, here I have this y, so I could substitute all of this in for this y. And then we have this y double prime. So I'm going to first rewrite y, and we're going to take the first and second derivative of that. So y equals a constant k, e to the power of negative 3x minus 2 sine of 4x. So y prime. Starting out, okay, so the constant follows along. So e to the power of negative 3x, it's chain rule, so times negative 3. I'm going to just write that out in front as negative 3k e to the negative 3x. And then derivative here, derivative of sine is cosine. And then chain rule, so times 4, which would be actually, so times 2 would be 8. So minus 8 cosine of 4x. And we need the second derivative. So same process. So this negative 3, if we do chain rule, has to be multiplied out in here. So we'll have 9k e to the negative 3x. And then derivative of cosine is negative sine, so this is going to turn into plus. Sine of 4x times 4 times this 8 is 32. So now if I look at this equation right here, I have y and I have y prime. I'm going to rewrite this substituting these long equations in. So you're going to need to write small for this next part. All right, so instead of y prime, I will put in 9k e to the negative 3x plus 32 sine of 4x, and now plus 16 times y, and y is k e to the negative 3x minus 2 sine of 4x equals negative 75 e to the negative 3x. This looks crazy. It looks complicated, but let's just go with it. What would you do if this was, now it's just like algebra. We have to solve for k. I have this 16. I'm going to distribute that 16. So 9k e to the negative 3x plus 32 sine of 4x plus 16 k e to the negative 3x, and then 16 times 2, negative 32 sine of 4x equals negative 75e to the negative 3x. Look at this. This term cancels with that term, and these two terms are like terms. So I can do 9 plus 16. So this all of a sudden simplifies way down to 25k e to the negative 3x equals 75e to the negative 3x. And if I want to solve for k, I'm going to divide both sides by 25e to the negative 3x. So these cancel. Forgot to bring down my negative right there. So then k equals, what is negative 75 divided by 25? Negative 3. Whew, so all of that, the answer was negative 3. If we go back up here, that answers the question. Oops. K, if it's negative 3, then if we plugged it in here, then this is the solution to this differential equation. So right there is your full video on verifying solutions for differential equations. Good luck.